All right, here we go. 11.5 angle relationships in circles. Our first thing that we're going to start with is a wonderful theorem. It says if a tangent, here it is, BC, and then a secant or a chord intersect at a point of tangency, there it is, B, then the angle that it's formed, angle ABC, is going to be 1/2 of that arc that it intercepts, AB. So let's do an example. I want to find angle EFH. Here's my tangent. Here's the chord. The theorem just said the angle is going to be 1/2 the arc it intercepts. So angle EFH is going to equal 1/2 of the arc FH. Well, I know this is 1/2 of 130. So angle EFH has to equal 65 degrees. All right, the next one wants you to find the arc GF. Well, GF is going to be twice as big as this angle here. I don't know what that angle is, but I do know that in a line there's 180 degrees. So if I take my 180 and I subtract 122, I get that this angle is 58. So if I want to find the arc, remember the angle is half of the arc. So in this case, 58 is 1/2 of arc GF. All I have to do is multiply by 2, and arc GF is going to be 116 degrees. All right, this next theorem, you guys, says that if two secants or chords, so if two secants or chord intersect in the inside of the circle, then the angle is going to be the sum of the arcs intercepted. So these angles are going to equal the arcs added together and then divided by 2. So let's try this. If I want to find angle AEB, let's call it X in this case, that angle is going to equal the sum of these divided by 2. So the measure of angle AEB is going to equal 1/2 of the arc AB plus the arc CD. So this is 1/2 of 139 plus 113. So this is going to give me 126 degrees. All right, I would like for you to try this one. In this case, though, they want you to find angle RNM. So there's an extra step there. I want you to solve and then come back, please. All right, so this one isn't included in those arcs that they give you, but I do know if I solve for this one, which I called Y, I could subtract it from 180 to find the X. So this angle is actually 1/2 the sum of the arcs. I found that that angle is 158 degrees. Then I took 180, the line, I subtracted 158, and I got my measure, which is just 22 degrees. More theorems, woohoo! All right, so we have 3 cases here. If a tangent and a secant, 2 tangents or 2 secants intersect on the outside of the circle, then the angle is actually the difference divided by 2. Okay, the outer minus the inner divided by 2. Outer minus the inner divided by 2. Outer minus the inner divided by 2. So let's try this example here. This angle X is going to equal 1/2 the difference. The outer, 87, minus the inner arc, 7, and then we're going to take half of it. So this is 1/2 of 80. So that angle X is just going to be 40 degrees. All right, you try this next one. It's a little bit different because the angle's given to you, but it's the same setup. Angle equals 1/2 the difference of the arcs. So try this, come back, and then we'll see if we end up with the same answer. All right, so 25 is 1/2 of 83 minus X. I multiplied by 2 first to get rid of that fraction, and then I solved. So this is going to be a 33-degree arc. Real life example, we've got 2 of the 6 muscles and that control our eye movement are actually attached to the eyeball and intersect behind the eye. So here's your eyeball. Here's those muscles, the supraoblique and the inferior oblique. I want you to notice they're tangents that attach at an exterior point. If I tell you that AEB right here is 225 degrees, and I want to know what this angle is, you should be able to use the theorem that we just did. That angle is going to equal 1/2 the difference of the arcs. The problem here is that we don't have this interior arc, okay? We do know, though, that this circle is 360 degrees. So if I take my 360 and I subtract my 225, it gives me that this interior arc is 135. So now that angle is going to equal 1/2 of 225 minus 135, which gives me 45 degrees. So what the heck did we just learn? We learned that if the vertex is on the circle, all it is 1/2 the measure of the arc. We learned if it's inside, if they cross and meet inside of the circle, here, then it's going to be 1/2 the sum, and if they meet outside, it's going to be 1/2 the difference. This is a good thing to have written down somewhere. This is the meat and potatoes of this lesson. So a challenge problem, they want you to find arc YZ. Here's YZ right here. All right? So you have a bit of a challenge. You have some information. I want you to pause. I want you to struggle with this for a little bit. Come back and I will show you how I solved it. All right, so going through this mess, I noticed that a straight line here makes 180 degrees. So I took 180 minus the 113 and it got me the 67 degrees right here. Okay? These cross in the inside, so 67 is going to be 1/2 of the sum of these. I use that to find this arc here, so 1/2 of 68 plus x. That arc is 66 degrees. Now that I have that, I can see this is on the outside. So 49 would be the large one minus the small one. 49 is 1/2 the large one minus the small one. I could find this arc by multiplying by 2 and adding 66. This is going to be more ideal as to what you're going to see. A whole bunch of crud on one circle, and you have to decipher how to solve this. Make sure you please come with your questions tomorrow. Have a good night, you guys.